Lesson 1.2.3, Determining Recursive and Explicit Expressions. In this video, we will determine unknown terms of geometric sequences using the explicit formula. Write an explicit formula for each geometric sequence. Then use the formula to determine the unknown term. Round the answer to the nearest hundredths when necessary. 7. Determine the 12th term of the sequence. So just like the arithmetic sequences, the geometric, we've got to find the first term and the common ratio. First term is pretty easy, it's 1. Common ratio, we're multiplying by 2 every time. So, we can say the second number divided by the first, which reduces to 2. And that's our common ratio. So then, I'm going to plug it into that formula. G sub n equals G sub 1 times r to the n minus 1. So G sub n is equal to 1 times 2 to the n minus 1. So that's our explicit formula for a geometric sequence. Now we can look for the 12th term. G sub 12 is equal to 1 times 2 to the 12 minus 1. So we can all subtract 12 and 1 and get 11. So 1 times 2 to the 11th. And then we're going to need to stick this in a calculator. So if you don't have a calculator in hand, you can go to Desmos like we did in one of the previous lessons. And under Math Tools, it has a scientific calculator. And you just tap on the click on the scientific calculator, and then voila, we can say 2, and then somewhere in here it lets us do to the power of, it's the a to the b, and then we go 11, and voila, we get 248. You could have also said 2 times 2 11 times and get that same answer, but there's a chance you'll make a mistake on that. So coming back here, we said it was G of (12) is equal to 1 times 248, which means that G sub 12 equals 248. So go ahead, pause it. I want you to try the next one. Okay, so now that you've tried it, hopefully you found that G sub 1 is 5, R is 4. You wrote out your geometric sequence, your geometric explicit formula, and then you plugged in 13 for n. 13 minus 1 is 12. You saw me use the graphing calculator or the Desmos to calculate 4 to the 12th, which is this number here. We do 5 times that number and we get our final answer. And that's how we use the explicit formula for geometric sequences.